Hello. All right, they're doing a little voice check here. A little voice check, looking pretty decent, I think. Maybe just a little bit more. All right. Alrighty, guys. Thanks for tuning in, all my YouTube subscribers, watchers, and viewers. Today we have a Taramps MD5000, the 1 ohm version, here on the bench for repair today, that we are going to do a quick diagnosis on, and we're going to figure out what's going on with this thing here. I don't see any visible damage, no burnt traces, no melted leads. So right now I see no physical signs of damage. So we're just going to see what we have for resistance here. Oh, what is this? 600 ohms. Oh, we have a shorted output. So 600 ohms, 600 ohms. Up 2.2. There's that one. 0.24. I'm not on a rectifier, am I? Nope, that's not a rectifier. Hold on, what do we got? SI 8244 drive IC, so we're gonna have a high and low 1 2 3 4 1 2 3 4 1 2 3 4. Oh wow, so they're just doing 2 and 2. Well, that makes things a little bit easier. So it's just 2 and 2. One of the first things I do is I differentiate where the rectifiers end and where my circuit starts. So this is you can see a line on the board right here. So these are rectifiers and these are power supply transistors. So these 4 here are output transistors, the IRFB 4115s. So we have 0.23 ohms here. Which could be causing my 600 ohms on the, I think that's actually low side drive there. I'm not 100% positive. Let me just cut this. We know this transistor is shorted, so I'm just going to go ahead and cut this transistor free out of the circuit. And I cut those legs right up at the transistor and not flush to the board. There, that's what we're looking for. So 10K, and then the other side, did we correct that? Nope, we sure didn't. 607, 605. I do believe that's going to be shorted. That's probably a damaged driver. Yep, so we're going to have 9.4K over 8.1, so we should be 8.1, and we're not. Let's go ahead and we're just going to remove all 4 of these transistors, these output transistors, and see if my 600 ohms clears or not. If the 600 ohms doesn't clear, then we know we have a shorted SI8244 drive IC. Let me flip this over. And I got the Hacko FR301 warming up, and in the meantime, while it's warming up, if you guys are interested in the products, tools that I use on a daily basis here, I do have links down below, my affiliate, Amazon affiliate links down below, that you can go browse through and see what I use. They are products, again, that I use every single day for the most part. So I would never steer you guys wrong on good stuff versus bad stuff. So let me clean the tip of the FR301 here real quick, just make sure it's clear. Yes, it is. All right. Go Grab the tweezers. So output section, oh, you guys can't quite see what I'm working on here. All right, output sections here, power supply sections here. You can always tell power supply because here's your primary power inputs. Power supply, transformers, output section. And you can see how they kind of laid out the output, or the bottom side of the board here, power supply section. This is your rectified area here. And then of course you have, it looks like they may have drawn out your output traces. So just to let you know on how they laid that out. So we're just going to go ahead and remove all 4 output transistors. Because again, we're trying to see if that 600 ohms will clear. Otherwise, we're going to be changing a drive IC. And anyone that does this knows that the drive ICs, the SI8244s, are extremely expensive and kind of hard to get. Gotta watch for my rectifiers here. 1, 2, 3, 4. I got one more to do here. So don't forget you have rectifiers next to the output transistors. They're the same size, package size, TO220. So it's easy to get going in a groove, and then all of a sudden you're pulling rectifiers out. And believe it or not, you know, some people don't understand the direction of rectifiers, or which goes back to not really understanding diodes. So if you pull the rectifiers and you don't know which way, because you have positive and you have negative rectifiers, and you have doublers, I mean, you have a couple types of rectifiers. But if you don't know which way they go back in, just leave me a comment down below. Get a hold of me. My website, ellensburgamplifier.com. I'm available 6 days a week, sometimes 7, just depends. 6 days a week. If you have any questions, all my contact information can be found at my website, on my website, ellensburgamplifier.com, which has a ton of information when it comes to, even has all my videos. I have a storefront that I have not worked on. I haven't had time to put my storefront really together yet, but I will be carrying Taramps parts for amplifiers. I already have the plastic ends, and I'm kind of working on keeping in stock the PICs for these. And of course I carry the components. And also I'm working on getting metal ends. I'm trying. It seems like they're kind of hard to get a hold of, but I've been working with Taramps to get some of the metal ends in. I did get a few in, so I do hope to start stocking parts for my website. Did we clear that 600 ohms? We sure did. 8.1, and that is exactly what we're looking for. So remember, I measure one side. We always have another side as a reference if the side didn't burn up. Over time, you start to recognize what the resistance value is for the particular board and what it should be versus what it shouldn't be. So I knew 600 ohms was wrong. That's an incorrect value for this board. 600 ohms is way too low. So we are 8.1 and N9. What did we say? 9.5 or 9.6? I can't remember. I'd have to go back on the video. 9.5K. So the drive IC on this is fine, which is fantastic, fantastic news. So we had shorted transistors, but we don't have burnt traces. However, it is a Taramps board. And for every Taramps board that I work on, I always reinforce the traces on the board, because this is where you're going to find that they do open up on you. Oh no. And of course, sometimes when I'm doing this, I accidentally solder the hole. When I get the new transistor in place, I will correct that. And get up in there and solder the, reinforce the factory traces. So these were the IFB4115s. Another common transistor. I always do recommend keeping the 4115s on hand. 415s, the 4127s, the 4227s are some of the most common transistors that you will want to keep on hand. Now, they shorted gate to source. And what do you have across the gate and source of almost all these amplifiers? You have a 15-volt Zener diode. So let me just grab my knife here real quick and get rid of some of this extra silicone that they so politely included. I'm just going to peel it right off the board because there's a Zener diode that's hiding down in there. But that transistor didn't short out. So since this was not a drastic failure like I've seen a lot of other amplifiers have, I am not going to worry about the Zener diodes. Because I believe, based on resistance, you can always, over time, start to learn there's a value, a resistance value to Zener diodes, which is, we are 7.2K, 7.5K, 7.5K, 7.2K. All right, so we're going to go over to the side that did not burn up. 7.6, 7.6, 7.5, 8.1. Oh, no transistors are installed. Oops. What am I talking about? Let's see here. 7.5 and 7.5. Yeah, so the Zener diodes themselves, I do believe, are going to pass the correct voltage. So let's get some what did I say these were? The 4115s? Let's get some 4115s over here. One, two, three, and four. 4115. 1, 2, 3, 4. All right, so we got the RFB 4115s here. Make sure the same date codes, even though you're really just two in parallel. But these are all the same. And I'm just going to bend the legs in small increments. Small increments to make that wide slope on the transistor legs to help prevent future vibration damage issues on the transistors. And I'm going to flip it over. And we are going to, oh, that's the transistors fall out of place. Solder these things in place. And I do it this way because it just gives me a little bit better precision, accuracy on the height, the position of the transistors. Just gives me a lot more control over the final position of these transistors. It's very important to remember and understand that these output transistors are dealing with some pretty substantial voltages. So anyone that's been around the electrical field or knows anything about it, that there's a threshold at what point voltage will actually arc. So we just want to make sure that all our transistor legs are soldered pretty secure. And of course, I like to make sure that the factory solder joints are adequate enough to carry the amount of current that this thing is going to put through. Excuse me. Flip it over. And then I got to finish soldering the original trace area from the factory here, just to help prevent future trace damage. I don't really see it much on the power supply. That's why I really don't do the power supply trace reinforcement. I always would just do the output, because that's 99% of the time it's an output failure. The output failures burnt the trace up. Very rarely do I have to do that on a power supply. I don't see many power supply failures. I see a lot of output failures. Probably because, I don't know, a lot of people ask me, well, why? I'm like, well, it could be because they just run the voltage really close to the maximum ratings of the transistors. There's many, many reasons why stuff fails. Can I tell you why those transistors failed? Not really. I don't know why they failed. So it was one side that was shorted. Probably, boy, I'm going to say it was thermal related. And when I say thermal related, well, you got to kind of understand, well, what creates the heat? What causes heat? What is heat? A good way to think about it is the heater that's in your wall. Takes electricity, puts it through an element, and that element gets hot, and then blows hot air out. Same thing with amplifiers. You put a subwoofer across an amplifier, it's a coil. Coil adds a load to the amplifier, components heat up, and the heat comes out. But these things can only tolerate so much heat before they fail. So, and of course, also a connected load. I mean, you could, what I say, this was a 1 ohm, this is a 1 ohm amp, so he could have been accidentally wired at half. He could have had a voice coil. It could have been something to do with the dynamics of the enclosure. It's hard to say, but usually you'll get an output failure from over temperature, overheating, too low of a load, stuff like that. So I just want to verify and make sure we're good to start this thing up. And we're going to go ahead and fire this up right here, right now. And see if we succeeded in repairing this. I already checked both sides for resistance. I don't show any shorts. The remote turn on circuit seems to be okay. So what I'm going to do is, I separate my remote leads here. One end is going into the remote of the amplifier, which is right over here, and the other end is coming from the power supply. What I'll do is I will clip it right to my mat, separated. I'll turn the power supply on. I'll look over to see my blue light is on. It's telling me that I don't have a short in the power supply, which I didn't see a short anyways when I was doing my checks. The voltmeter at the back end of the amplifier to tell me what the DC offset is. Now let's see, do we get a blue light? Uh-oh, no blue light. Maybe my remote is not making contact. Oh, there we go. My remote was not making contact. My poor alligator clip that I'm using for my remote turn on is kind of bent from a previous, what we call that, a rapid turn off of an amplifier. It didn't start up the way I wanted it to. So, all right, so we're going to go ahead and start this up and see and make sure we don't have any rapid disassembly of transistors. All right, we are fired up. 0.01 volt DC offset, kind of high on the DC offset, and we do have a dead fan. You double check for heat. I'm just going to use my fingers. I'm going to touch the tops, not the tabs. Don't touch the tabs of the transistors because there's going to be some high voltage on one of those. So they're not hot. So I'm going to go ahead and let it run just for a second here, because I'm going to adjust the DC offset down just a hair. 0.00 0.002. How does that sound? .002 of a volt DC offset. I mean, it'll bounce around a little bit, but nothing too high at all. But we do have some pretty unfortunate sick fans. So got the DC offset set right where I want it. And then from here, we just take care of the fans, which probably, it might still work. Maybe it's stiff. That means the grease in it is all solid. But I'll take the fans out. We'll get the fans rebuilt or replaced and move on from there. So there it is, guys. A quick, simple MD5K repair of an output section. And we got it fired up and we got the DC offset is set. So if you have any questions, please leave them down below. I will get to you as soon as I can. I love answering and helping people keep these things out of the ground. So, and also I do have, again, my affiliate links down below. If you have any questions about what I use, materials, tools, items, I do have my Amazon affiliate links down below. So please check them out. And as always, safety is #1. It always has been throughout my whole life. I am a retired industrial electrician, so safety is always first. Please remember the voltage on these is absolutely horrendously high on the rectifiers. These rectifiers here do carry voltage. There is pull-down resistors of 33K, so it does take a little while to discharge these rail capacitors. So keep your fingers safe from these rectifiers, and it'll give you a good day. If not, it'll give you a bad day. So stay safe. Thanks, guys, for watching. We will catch you on the next one.